include the today's cash flow in the net present value function. So always when you use the net NPV function, include all the future cash flows, but add back the initial cash outflow. Okay, so that's how we calculate the net present value. And to write something here, right? So this 100 means that when we calculate, in this case, the difference between the initial cash outflow and the present value of the future cash inflow, like 110, and discount rate is 10%, right? So it's 1.1, 121 over 1.1 squared. So difference between present value of the future cash flow and the initial cost is the net present value, right? So in case of project A or the machine A, net present value is the difference between initial cost and the present value of the future cash flow, and that is exactly $100, right? And we can do the same for the second one. And because we locked the reference cell, now all that we have to do is to include E5, right? So in case of the second project, so let me use a different color. So net present value, this is crazy color. Net present value of the second project is negative 120 plus the present value of all this, right? 110, 121, and 133, right? And that is 179. I went too far. Okay. Oops. Okay. So that's the basics of how to do a net present value calculations, right? And when we go back to the whiteboard, and I told you that one of the things that we have to cover in the chapter 8 is how to calculate the net present value, how to calculate the internal rate of return, and also understand the difference between NPV, internal rate of return, and EAA and EAC, right? And in case of internal rate of return, this is simply the discount rate that makes the NPV equal to 0. So IRR. Right. So going back to this example, right? Right. So when we calculate the internal rate of return here, internal rate of return is very easy to calculate. We all know how to do it. We have done this for some time now. So you just open up a parenthesis and highlight all the current and the future cash flows, right? And in this case, this is 78%. And in case of the machine B, this is 81%, right? Okay, So think about what this means. So when I erase all this, right? Oops. So in case of project A, right? In case of project A, we talked about the NPV, and its NPV was negative 100 plus 110 over 1 plus r, and 121 over 1 plus r squared. And this was NPV, right? So internal rate of return is the value of r, value of this r, the value of this r that makes entire net present value equal to 0. So what it means is that when the value of this r is a 78%, right, 0.78, the value of this NPV is equal to 0. Does it make sense? Right? So going back to this one. Okay. So again, let me write that equation again. So NPV of the machine A was so when you look at the relationship between R and the NPV,
Right.
if you look at the relationship between R and the NPV, any increase in R, right, any increase in discount rate will not really affect the initial cost, right? So any increase in R does not affect the cost side. It's only going to affect the present value of the future return. So think about what will happen to the NPV as the discount rate goes up. So when the discount rate goes up, value of these denominators will increase, right? And because of the present value of the future cash inflows will decrease, but the cost doesn't change. So as the discount rate goes up, net present value actually decreases. So when we draw a chart that shows the relationship between NPV and the discount rate, so say this is not great. So this is the vertical axis, and this is the horizontal axis, right? And the horizontal axis is the discount rate, and the vertical axis is the net present value. Then, because of the inverse relationship between the discount rate and the net present value, when we draw a chart of the net present value and the discount rate, the chart will have a monotonic negative slope like this. Okay, so what the internal rate of return tells us is internal rate of return is the value of R that makes the net present value equal to 0. So that's here, right? So this is the internal rate of return. Okay, so internal rate of return is the value of R that makes the net present value equal to 0. Okay, so going back to this one, we learned that internal rate of return of project A was a 78%, right? So this is 78% or 0.78. Okay, and then what is the value of NPV that we calculated? In this case, the opportunity cost of the capital was at 10%, right? it means that the discount rate the company use is at 10%. So when the discount rate is 10%, which is here, right? When the discount rate is 10%, value of the net present value of the NPV was exactly $100. Okay, so what this means is that when the internal rate of return, which is 78%, is greater than the discount rate, which is 10%, right? Net present value is also greater than 0, right? So that's the reason why internal rate of return and the net present value usually agrees. If there is a project that has a positive net present value, that means that that's a great project, right? So by investing in that project, the company will make money and increase the profit. And when you calculate the annual rate of return of that project, the annual rate of return of that project will be greater than the opportunity cost of the capital. Okay, any questions about this? No? Any questions about how to calculate the net present value or the internal rate of return?
Professor, can you go over calculating the payback period?
Oh, sure. Well, we don't really go over the payback period because it's such a silly criteria. It's a good thing that you actually read the textbook. And the payback period, it basically is the number of period that you need to get your initial investment back, right? So, for example, in case of the machine A, your initial investment is $100, right? And in year 1, the net cash inflow is a 110. So the payback period is 1, right? In case of machine B, your initial investment is 120, and the cash inflow of the machine B in year 1 is 110. So you have a longer payback period, right? So according to payback period, machine A is better than machine B because you will get your money back sooner. That doesn't mean that the project A is actually better project than project B, because when you look at the net present value, project B has a higher net present value, right? Also, when you look at the internal rate of return, project B has higher internal rate of return. So what it means is that when you invest in machine B, you will make the total profit of $179 over your next best alternative project, right? So instead of investing in machine B, if you invest in the market, you're going to enjoy 10% return, right? So that's the concept of the opportunity cost of the capital. So if you invest in the machine B, instead of investing in an alternative project, you're going to make $179 more over the 4 years than your alternative project. Does it make sense? Okay. And the reason why your profit is so great is because your annual rate of return from that investment is whopping 81%.
So a more risk-adverse investor would invest in machine A due to like the payback period because they would get their money back quicker?
That's a good question. I'm not, so here, we didn't really talk about the concept of the risk, and we will talk about introduce the concept of the risk later. But your instinct is right, because obviously project A, no, actually machine B here, machine B is riskier investment compared to machine A simply because its duration is longer, right? So if there is any change in the discount rate in the future, net present value of machine B will fluctuate more than the net present value of the machine A, right? However, that doesn't mean that you should still use the payback period. Payback period is a terrible criteria. So yes, you can get your money back early here in case of machine A, but when you invest in machine B, you will get a whole lot more money in the following year, especially in year 3.
So when you ask us to find the payback period on the problem set on question number 3, is that we just eyeball it, or do you use a formula for that?
Well, you can use the formula, but that formula itself is also so simple, right?
Yeah.
Yeah, so you can just use an eyeball. I mean, it's, but surprisingly, people actually use the payback period a lot because they want to check the bottom line of an investment project.
Sure.
Yeah. Any other questions? I don't know why this annoying page 1 thing is showing up here. Any other questions about this? All right. Now, let's talk about let me move this whiteboard a little bit so that I can easily add a new page. Oops. Okay, so I'm adding a new page now. So what I'm going to talk about now is the pitfalls of internal rate of return. Right? So usually what happens is that there is an inverse relationship, simple monotonic inverse relationship between internal rate of return and the net present value. So NPV and in the internal rate of return usually agrees, right? But when we talk about specific project, so the first case was the case of multiple IRR. Okay, so when there are multiple cash outflows in a project, okay, then when you calculate the internal rate of return, because the relationship between the discount rate and the NPV is not monotonic, the internal rate of return will give you, 2 different numbers. And that's what we saw in the problem set and also in your textbook. So let me turn this thing on. Okay, so let me share the PowerPoint here. So do you guys have access to Excel? If you have access to Excel, try this project. So this is the project that we went over in the previous class. So this is a really typical mining project. So in this project, there is initial cash outflow, right? You build the mine, then the mine will produce minerals and ores and generate the cash flow. And when the project is over, now you have to pay a cleanup cost. So there is an initial cost and there is final cleanup cost, right? And because of this, when you look at the relationship between the discount rate and the net present value, the relationship between the two is not a monotonic inverse relationship anymore, right? So given the definition of the internal rate of return that makes the net present value equal to 0, now we have two different internal rate of returns, and also neither of them are correct. Okay, so whenever you face a project that has multiple cash outflows, and also the kind of cash outflow that happens in the future, you run the risk of facing this kind of problem. Okay. So in the video, I went over this case in detail. So let me go over here. Do you guys see the Excel file now or no? Do you see the PowerPoint? Okay. All right. So let me share the new Excel file. So this is the Excel file for the king call example. Okay. So this is the cash flow, right? So you initially spend $210 million, right, to develop the mine, right? So this is the initial cost. Then these are the cash inflows, right? Then there is a final cleanup cost. So when we calculate the internal rate of return of this, right, you can easily calculate the internal rate of return. It says that the internal rate of return is 3.09%, right? And let's say the discount rate of the company, the opportunity cost of the capital is 5%. Then your answer should be, wow, you know, the internal rate of return of this project is lower than the discount rate, so this is a terrible project. We shouldn't initiate this project, right? The problem is that when we calculate the net present value using that 5% discount rate, as we see here, the net present value is a positive, which means that this is a good project, right? So this is an example in which net present value and the internal rate of return tells you two different stories, right? And the reason is because the relationship between net present value and the internal rate of return is not monotonically negative. Okay. So how do we deal with this problem? The first rule of thumb is whenever there is a disagreement between net present value and the internal rate of return, always trust the net present value. So if the net present value tells you that this is a good project, this is a good project, right? Second one, this doesn't really solve the problem of the internal rate of return, right? So for example, if your boss asks you, so what is the rate of return of this project? You cannot say that the rate of return of this project is 3.09%, because in that case, you shouldn't initiate this project, right? So one way of dealing with this problem is to use the modify the internal rate of return. Okay, so in case of the modified internal rate of return, it is more flexible in the base assumptions than the internal rate of return. So in case of the internal rate of return, it always assumes that any kind of cash inflows that the company has generated will be reinvested at the rate of the internal rate of return. Right. So for example, when the company generates the first positive cash flow of 125, internal rate of return assumes that this 125 can be reinvested and earn exactly the same rate of return as the internal rate of return of this entire project. Okay. net present value has a different assumption. In case of net present value, it assumes that these cash flows will be again reinvested, but they are going to earn the market rate of return. So in case of NPV, the assumed reinvestment rate is the discount rate. In case of the internal rate of return, the assumed reinvestment rate is the internal rate of return itself. Right? So that's one of the sources of the discrepancy. So when you look at the MIRR function, so let me show you. Type in equal MIRR. When you open up a parenthesis, it'll ask for the values. So we will highlight all the values. Then it'll ask for the finance rate, which is the discount rate, basically, right? Right. And C1. And then it will ask for the reinvestment rate. So we can actually determine whether the company can reinvest at the rate of the discount rate or any other rate. So in case of NPV, we are assuming that any cash inflows can be reinvested at the rate of discount rate. So we will just say discount rate again. Right. Then when you press enter, you will see that now we have a different value from the original internal rate of return. And you can see that this is actually more consistent with the net present value, right? So according to the modified internal rate of return, the annual rate of return is 5.17%, which is greater than the discount rate of 5%. So according to the modified internal rate of return, this is a good project. The rate of return from this project is greater than the opportunity cost. And also, according to the net present value is a positive, which means that this is a good project. So now these two agrees. Okay, so that's one way of solving this problem. Okay, another one way of solving this problem is, to understand that the source of the problem is that there are two separate cash outflows. Right, so there is a cash outflow here, cash outflow here. Right, so one potential solution to this problem is that eliminating this cash outflow. Right, so calculate the present value of this $400 and add it back to the initial cash outflow, like this. Okay, then now we have a really typical profile of a project. So there is an initial cash outflow and then all the future cash inflows. Then we can use a simple internal rate of return function and calculate the rate of return. And you can see that the net present value of this project is exactly the same as net present value of this project. So the net present value doesn't change. And we can see that the internal rate of return has increased, and also now it is consistent with the conclusion of the net present value. Okay. Any questions about this one? So what's the take-home message here? The take-home message is that whenever you deal with a project that has a multiple cash outflow, especially in the future, do not use the internal rate of return. Okay, and use either the modified internal rate of return or eliminate the future cash outflow by calculating the present value of that future cash outflow. Okay.
Can you go over how to calculate the modified rate of return in Excel again?
Sure. So this is how we calculate the modified internal rate of return. So when you open up the parenthesis, right? So type in equal MIRR and open up the parentheses. Then it'll ask for the values. So just like the internal rate of return function, you highlight all the cash inflows and outflows. Then it'll ask for two separate informations, finance rate and the reinvestment rate. So to make this really consistent with the assumptions of net present value, make the finance rate and the reinvestment rate equal to the discount rate. Then you'll be able to get the modified internal rate of return. Okay, so let me show you this. Okay, any other questions? Anthony, did you want to say something?
No, I was kind of wondering, like, when you use modified rate of return, but then I figured it out, so I'm good.
Okay, good. Any other questions? All right. Then the next one that we need to talk about is two mutually exclusive projects. So, so this is, again, from your textbook, right? So let's say you have two mutually exclusive projects. So you have a building that you want to buy, right? So you have two options. You can buy the building and hold it for 3 years. So that's what you see here. So that's the long project. So you spend $350,000 to buy the building and get the rent of $16,000 every year, and then sell it at the price of $450,000, right? So that's option one. Option two is to buy the building at the same price, but instead of holding it for a long time, you just sell it at the price of $400,000, right? And because we are talking about the same building, you cannot initiate these two projects at the same time. So if you choose one, then the other cannot be initiated, right? So that's what you call as a mutually exclusive. So in case of mutually exclusive project, sometimes internal rate of return and the NPV do not agree, right? So as we can see here, when we calculate the internal rate of return of the long project is a 12.96%, and the NPV is a 59.32. And internal rate of return of the short project is a 14.29%. So according to the internal rate of return, right? According to the internal rate of return here, this is greater, right? Short project is better than the long project, according to the internal rate of return. But according to the net present value, long project is better, right? Has a higher NPV value than the short project. Why does this happen? Right? Do you guys remember the concept of the interest rate risk that we learned in the financial markets class? Right? The idea is that long-term project is riskier than the short-term project because long-term project is more sensitive to the changes in interest rate than the short-term project. Long-term bond is riskier than the short-term bond. It's exactly the same logic. So think about the relationship between NPV and the discount rate, right? So this is, again, the net present value. And this is the discount rate. Right? And think about the NPV profile of the short-term project. So say this one is for short-term project. Okay. Because short-term project is just like a short-term bond, its net NPV is not as sensitive to the changes in interest rate as the long-term project. So its NPV profile is more flat, like this, right? And we know that its internal rate of return is a 14.29%. So this is a 14.29%. Right? The discount rate that makes the net present value equal to 0. Think about the long-term project, right? This one. In case of the long-term project, because it's a long-term project, it's more sensitive to the changes in its NPV is more sensitive to the changes in interest rate. So when you look at its NPV profile is steeper, like this. Let me try it again. Right? Its NPV profile is steeper, even worse. Like this. So this one was a short-term project, and this one is long project. Right. So in case of long-term project, because it's more sensitive to the changes in interest rate, it has a steeper profile. Okay. And when you look at the internal rate of return is the value of R that makes the NPV of the long-term project equal to 0. So this is 12.96%. Okay. Now, what is the discount rate? According to the question, the discount rate is here, 7%. Right? So when the discount rate is 7%, which is here, right? What is the net present value of the short-term project? Net present value of the short-term project is the point on the red line, right? And this is 23, right? What is the net present value of the long-term project? Which is here, and this is 59.32. Okay. So this chart illustrates the difference between internal rate of return and the net present value, right? And also highlights one of the limitations of the internal rate of return. So in case of net present value, when you calculate the net present value, you have to use the market rate of return, the discount rate, right? In case of the internal rate of return, you don't pay attention to the market rate until you actually get the internal rate of return, right? So that's one of the limitations of the internal rate of return. And that's the reason why, in this case, internal rate of return and the NPV tells you a different story. And just like any other case, whenever there is a disagreement between NPV and the internal rate of return, NPV is correct. Okay, so you should go with the project that provides higher net present value. Because when you calculate the net present value, you consider what the rate of return from your alternative project is. Okay. Or to put it in another way, the reason why the short-term project is not a great project is because you enjoy high return from the short-term project while the project is still going on, right? So in the first year, you enjoy really high return of 14.29%. Then in year 2 and 3, what do you do? In year 2 and 3, this is the rate of return that you will enjoy. So when you initiate the project, short-term project, in year 1, you will get $400,000. And then that $400,000 will earn the return of 7% in year 2 and in year 3. That's the assumption of a net present value. Okay. Instead, if you invest in the long-term project, which lasts for 3 years, right? Then your annual return is 12.96%. So every year for the next 3 years, you are going to enjoy 12.96%. So that's the reason why overall, when you look at the profit, net present value of the long-term project is actually greater. Okay. Any questions about this one? So what's the take-home message here? Take-home message here is when you deal with the mutually exclusive project, again, do not trust the internal rate of return, right? Because internal rate of return has very strict assumptions on how the money is reinvested. Okay. Any questions about this one? No? All right. Then let's go over the last one, which is the EAA and EAC. Okay. So again, whenever we talk about the EAA and EAC, we are talking about first, mutually exclusive project, right? You have to put a rank on two different projects. Second, the lifespan of the two projects is different. If the lifespan of two projects is the same, you don't need to calculate the EAA or EAC. You can simply use the net present value. Okay. Now, I told you that mutually exclusive. Project with different lifespan. So when these two conditions are met, now we have to introduce the concept of EAA. Okay. So I told you that the assumptions on the reinvestment rate is very important, right? So in case of EAA, right, unlike NPV, we are assuming that these projects are recurring projects. So for example, in case of this machine A, right, when you buy machine A, this thing will last for 2 years, right? Then in year 3, what happens? In year 3, what happens is that we are assuming that this machine can be bought again and again and again, right? So instead of reinvesting this money in the next best alternative and getting the 10% return, now we are assuming that this machine can be bought again and again, right? So EAA is used when we deal with the recurring projects. Okay. So, we can imagine a case like, should I buy a expensive car that costs more money initially, but may last longer and provide a greater benefit versus buying a cheaper car, which may cost less initially, but may not provide as great benefit and also may not last longer. But when a car breaks down, you have to buy a new car, right? So this is a recurring project. So whenever we deal with a recurring project, calculating the net present value is not enough, right? Because net present value assumes that we are dealing with just a one-shot project. Okay, so what we have to do is we have to calculate the net present value first. So in this case, we can calculate the net present value like this. And highlight the future cash flows. Okay. Go back here. And always add back the initial cost. Okay, so this is the net present value of the machine A. This is the net present value of the machine B. So you can see that the net present value of the machine B is better, greater than the net present value of machine A, right? But this works if we assume that this is just a one-shot project, and after the project is over, any kind of proceed from the project will be reinvested at the rate of 10%, right? But if there is a possibility that these projects can be repeated, right? Then if you buy machine A, this will generate the cash flow of 110, 121, 110, 121, 110, 121 in every 2 years. If you buy machine B, it'll generate the cash flow of 110, 121, 133 every 3 years. And every 3 years, you will have to pay the cost of 120, right? So how do we properly compare these two? The problem that you deal with is that when you try to compare these two options, their cash flow is not even. There's too much fluctuations in the cash flow. So it makes the comparison much more difficult. So one solution to this problem is to turn these cash flows into a steady cash flow, like an annuity, right? So if you can turn this into an annuity, it'll be much easier to compare them. So that's where the idea of the EAA comes in, right? So that's the equivalent annual annuity, right? So you turn this NPV into an annuity, and you can do that by dividing the NPV with the annuity factor. Do you guys remember the present value of an annuity equation? Present value of an annuity is the annual payment times the annuity factor, right? So if you want to know the steady stream of annual cash flow, steady stream of the annual cash flow is present value over the annuity factor. Oops. Right? So all that you have to do now is instead of present value, you do the same thing with the net present value. So this is EAA. So equivalent annual annuity is net present value over the annuity factor. Okay. And do you guys remember how to calculate the annuity factor? Right? So this is the annuity factor. So we have to calculate the annuity factor here using the 10% discount rate. Right? So this is because this is a 2-year project. This is the annuity factor, right? So annuity factor of a 2-year project is 1.73. Right? Annuity factor of 3-year project something is wrong. This is pretty large number because I guess probably because the discount rate is high. Oh, sorry. I thought this was strangely high. Right. Sorry about that. So annuity factor of the 2-year project is 1.74, 3-year project is 2.49. So EAA is simply the net present value over the annuity factor. Right. So what it means is that when machine A and B are recurring project, right? Keep buying the machine A every 2 years is equal to getting the cash inflow of $57 every year, and keep buying the machine B is equal to getting the cash inflow of $72 every year, right? So buying the machine B is better according to the EAA calculation, even when you allow these projects to be repeated. Okay, so the key point here is that in case of EAA, we are talking about 2 mutually exclusive projects and project with a different lifespan. And when we assume that these projects can be repeated, we should use the EAA, not the net present value. Okay. Any questions? No? Okay. Now, let me ask you this question. Was there any specific question in the problem set that you wanted me to go over? Five C, right? So let me show you what the 5C is. Right. So this is exactly the same problem that we just went over, right? So we calculate the net present value, we calculated the EAA to show that machine B is actually better, right? Then take a look at the part C. So there is a machine C that was purchased 2 years ago for $90 and produces the annual cash flow of $80, right? it has no salvage value. So by selling the machine C, you don't get any additional money, but it is expected to last another 2 years, right? Now the question is, should you replace the machine C right away, or should you wait until the end of year 2, right? There are 2 relevant informations here. One is it generates the cash flow of 80, right? The other one is its price was $90. Okay. Shall we pay attention to this cost? The answer is no. Why? Because this is what you call as sunk cost. So you already spent this money and you cannot recover it because it has no salvage value, right? So when you make a decision, you should not pay attention to the sunk cost. So the fact that you spent $90 should not matter anymore, right? But what matters to you is that this machine can generate $80 cash flow annually, right? So this is basically the EAA of the machine C. So machine C generates the cash flow of $80 for the next 2 years, right? And compared to that, when we calculated the EAA of here, when we calculated the EAA using the Excel, what was the EAA of A and B? EAA of A was $57, right? And EAA of B was $72. So if you have to choose between keeping the machine C versus replacing it with the machine B, which one is better? When you replace it with the machine B will annually generate the cash flow of $72. Machine A is currently generating the cash flow of 80. So keeping the machine C is better, right? The fact that you spent $90 in the past should not matter. Was that answer to your questions, Lalisa? All right. Any other questions? Okay, that's it for today. So I will put the recording of this video, this session on Moodle so that you can go back and watch it again. And also I will continue to make the recording of separate instructions. I think it would be great if I can get an honest feedback on those videos so that I can get better in making videos. All right. Any last minute questions? All right.
Sorry, how do you want us to do problem sets? Are they still, do you want them to be more individual now, or are they still group?
I think it'd be still better if you can do it in a group. And, as I told you in the email, I created the assignment bin. So I think it'd be better if you can, submit your group assignment in that assignment bin. Any other questions?
Do you want us to hand in the problem set through Excel, or what format do you want us to do that?
The ideal format is to use the Word document and embedded the Excel file in the Word document.
Okay.
Yeah, it actually increased the size of the file significantly, but it's actually much easier to review your problem set that way than going through the Excel file.
Perfect.
Yeah. Any other questions? right? Thanks for coming to our first session, right? Hopefully I will get better in the future. And for the next class, you need to read the chapter 9. And chapter 9 and 10 are incredibly important chapters. So they are the discounted cash flow chapters. So DCF model is so widely used, and also things will get a lot more complicated. So you will need a much bigger Excel file. So in chapter 9, we will introduce the DCF model. In chapter 10, we will do the sensitivity analysis of the DCF model. And sensitivity analysis requires really, really heavy use of Excel. And I will introduce many different techniques of doing the sensitivity analysis, especially the table function. So I'll make separate videos for chapter 9 by the end of this week, so that you can start reviewing the chapter 9 contents using the video. But I think it'd be really great if you can read the chapter 9 of your textbook carefully. Okay. All right, guys, stay safe, and I will see you next week.